It's one thing to look at a graph and say, okay, what's its domain, what's its range? I just look for all the values for x where, in fact, the function sort of is colored in somewhere up or down, and the range just ask for, all the heights for which the function will finally cross at some point. But it's another proposition completely to look at just the algebraic expression for a function, for a graph, and ask, just from you looking at the algebraic expression, how do you go about determining its domain and range? Well, the domain actually is really important, and so we're going to look at a lot of examples of those in a second. But I thought we'd just take a moment to look at one function and find both its domain and its range by just looking at it algebraically. So let's consider the following function. F of x equals 2x plus 5. Okay, so it's thought of as a linear function because I just have x appearing to the first power. And let's first of all find the domain and then the range. Okay, well, what's the domain? Well, if we're thinking about the domain, remember the thinking here is, what are the permissible x values that I'm allowed to insert for x that would actually produce numbers? So what I have to ask is, are there any values for x which would make this thing undefined? Well, if you think about it, no, there are no values for x which would make this undefined, because any number you can ever possibly think of can be multiplied by 2, and then that quantity can be added to 5. And so, in fact, this is defined for all real numbers. So the domain would be all reals. Sometimes by the real numbers are just denoted by it looks like a bold-face R, but it's not. It's like sort of 2 bars and then an R. So all the real numbers, so all the x values possible. By the way, where would you be in a position where, in fact, that wouldn't be the case? Well, if you ever had a fraction as a function, then wherever the denominator were to equal 0, those would be points that you'd have to remove from the domain because you can't have 0 in the denominator. The other classic place to look is if you have square roots, you want to make sure the stuff inside the square root is always positive or 0. So any values for x which would make the inside of that square root negative, those would be points that you would have to exclude from the domain. But here, very nice, clean, simple, no problem. So we have everybody. What about the range? Well, that's sort of the targets, right? What possible values can this take on as x goes through its domain? Well, if you think about it, it could be any value at all. Because suppose you said to me, gee, I want to find out if this function will ever hit the number 23. Suppose you want to hit 23. Well, all you have to do is say, let's find the x so that y value will equal 23. Well, now you can solve this, right? How would you solve this? I would say 2x equals, I guess it would be 18. And so therefore x would equal 9. And notice if I plug in 9, f of 9, so here's a little check. F of 9, I'm using this notation, that means wherever I see an x, I plug in 9. That's going to be 2 times 9 plus 5. And notice that's 18 plus 5, which is 23. So I hit the y value, 23. But in fact, you can see that I can hit any value I wanted to, because I would just take 2x plus 5 and set it equal to that value. I can always solve that equation. It's a linear equation. So I bring this over and divide by 2. So in fact, the range, the y values that I possibly hit, turn out to be all the real numbers as well. So here's an explicit example where, without looking at the picture at all, I was able to see what the domain and the range is. Now, let me show you the picture, because I happen to know what the picture looks like. This is actually going to be a straight line. So let me show you. Let me put in the axes here, really fast here. I'm not going to spend too much time on this. But if here's the graph, so here are the axes. Well, it turns out that this graph looks something like this. Roughly speaking, looks like that. So it's a line that shoots out this way. And you can see that every single value of x is allowable to plug into this line. Now, of course, it goes right through my head and stuff, but it keeps going, even though I'm standing there. And similarly over here. So in fact, you can see that the domain is everything. If you sort of take this thing and project it down, you sort of get everything. Similarly, if you now look at the y values you can get really, really high y values, but you also get really, really low y values. We get all the y values. So now you can see graphically that, in fact, the domain and the range, in fact, are both all the numbers, but we were able to do it without even looking at the graphs. What I want to do next, is to take a look at a lot more complicated functions, and there the question is, find the domain, find the allowable x values that we can put in as input. I'll see you there.